All right, so to begin with, we look at networks, which is basically a group of connected computers and devices that share resources together. Um, so in this example here, we're looking at some key reasons for having a network. In this picture, at the center, we have centralized control and security. So when you have a centralized control and security, it's basically having the network administrator to manage the users on the network, to manage files, to manage software and security settings from a single location rather than on individual computers. Now, so that is the first reason for having to share a network, right? The next reason is resources. So resources here, we're looking at printers and storage devices. So multiple users can share hardware and software resources, in the process reducing costs and improve efficiency. So several computers can use the same printers, and then in the same sense, users can access shared software installed on a server, and then storage devices can be shared across the network. Another benefit has to do with communication. So for communication, users within the network can quickly send emails between each other. They are able to use instant messaging or chat applications, and then also they can hold voice or video conferencing. And then finally, for data sharing, users can access, share, and work on the same data from different computers. So, example, employees accessing a shared network database can, work on the same data. And again, student collaborating on shared document. And then we can have teachers storing lesson materials on a shared folder for students to access. So these are some key reasons for having a network. For every network, there's a network interface card that allows the device to connect to a network, and each network interface card has a unique MAC address. Now, mostly there are two main types of network interface cards: the wired and then the wireless, which is the W and IC. Uh, in this picture here, this is the wired one that has a two ports, and the rest are wireless. All right. Now we want to look at MAC addresses. So MAC addresses basically um, means media access control address, or also called the physical address, is a permanent and unique identifier for every network device, and it's made up of 48-bit hexadecimal address. Now, MAC addresses are used by network administrators to troubleshoot in order to track fault within the network devices on the network. Now, again, they are used by switches to send data packet to the correct device on the network. Unlike IP addresses that changes, the MAC address does not change unless you change the network interface card. So the IP address, which is in full the internet protocol address, is a logical address that identify a device's location on a network. So, for example, if you're using your computer from a cafe, the IP address you have will be different if you move to your home, right? So the IP addresses changes and helps to identify your location on the network. All right. So that is it for IP addresses. Now, there are two versions of the IP addresses. We have the IP version 4 and IP version 6. So the IP version 6 was introduced because the IP version 4 has been exhausted. Okay. All right. Now, if you want to check your IP address and MAC address, all you have to do is to go to the search button and look for CMD and hit enter. And once you type in ipconfig/all, it will display your MAC address and the IP version which you are on, or the IP address you are using. All right, so that is it for MAC addresses and IP address. Next, we're looking at data packets. All right, so Data is broken into small packets before it's been transmitted across a network. And each data packet has three parts: the header, the payload, and the trailer. For IG, our interest is on the header, right? So you need to know the component of the header of every data packet. And in those data packets, we have the sender address, you have the receiver IP address, we have the sequence number, the packet size, and the total packet number. So basically, this is how routers use packets. So they receive a packet at one point and they have to check the destination IP, compare it against a routing table, and then they forward it to the next router to it gets to the right device. Now, once the packet data hits the right device, it's reassembled into the correct order using a sequence number. So the key concept we want to get here is that data is never one block, right? So it's always split into packets and they travel independently across different. So this is what we mean by traveling different on different paths. Now, so if you look at this computer here, it's has is going to send data, but that data will be broken down into various packets. So packet 1, 2, 3, and they're going to go through different routers 1 to 4 in order to get to the web server. So if I send a data from this guy here, it goes in data packet and gets to the web server. All right. So basically, that is all there is to data packets. Right. Next, you have a short test to test your understanding on data packets. And so here the question says, state 3 pieces of information found in the data packet header and explain the purpose of one of them. So I encourage you to pause the video and attempt to answer the question. All right. I want to believe you got the answers right here in the sample answer provided. If you did not get it, you can go back and review on what we have said about data packets and come again to attempt the questions.